All right, in concept H, we're going to be focusing on another type of reaction, a single replacement reaction, and learning how to write those correctly. I would make sure that you have your reference table out and in front of you and open to table F, because we're going to be using that quite a bit. All right, so as you already know, this is when an element replaces another element in a compound. But specifically, this reaction can only occur when a more reactive element will replace a less reactive element. So you may want to actually label it. This A, representing an element, has to be more reactive than, in this case, B. This has to be a less reactive. And how we're going to be able to tell is by using table J, which can help us predict if the reaction will occur, which we will say is spontaneous if it does. And we have to see that A is more reactive than B. And how we would do this with using table J is the higher the element is, the more reactive it is. The lower it is, the less reactive. So we're making sure that in the symbol A in the previous equation, that it's higher than the element B should be below it in order for the reaction to happen. So looking at table J and at these 5 examples, we're going to check and see if this reaction will occur, yes, or if it's going to be non-reactive. So here we're looking at potassium being higher than strontium. So if I come over to the side here, you'll find potassium, and then we do see that strontium is below it, so strontium is less reactive. So we can say that yes, this reaction will occur. So if you want to, you can pause and try out the rest by yourself. Here we're looking at cobalt is lower than strontium, so this will be no reaction. Because cobalt isn't reactive enough to replace strontium. Here we have zinc and hydrogen. Zinc is right here on table F. Hydrogen is below it. So that means then that yes, zinc is more reactive than hydrogen, so zinc will replace hydrogen. And then for the next one, we have silver, which is Ag, which is down towards the bottom, and then as we can see, Al is above it, so strontium is less reactive than aluminum, so this will not react, so no reaction. And then finally, we have chlorine, or we have bromine and chlorine, which actually means we're using the right-hand side. Chlorine is above bromine, so that means then that yes, chlorine is more reactive, so it can replace bromine, so we can place a Y there. All right, so now that once we know that we have these, you can see that I also have this in a lovely red. We can now go ahead and only write the reactions for the ones that actually occur. So 2 and 4, we're not going to write a reaction for because those won't happen on their own. So initially, we want to make sure that we're just going to simply show potassium taking the place of strontium. However, we do have to check their charges because here strontium was a +2, but we now also know that potassium is just a +1. So we have KCl plus we then have strontium. Now strontium we need to know as an element is a solid at STP, but however for KCl we actually have to use table F in order to figure out what will happen with that phase. So we want to look at table F. We're looking at the negative ion. So here we have Cl, okay, right here on table F. Normally Cl is soluble, except when it's combined with silver, lead, and mercury. Now it's combined with potassium. So that means then if it's soluble that we can place an AQ next to its phase, meaning that this compound would dissolve in water. Because we already know there's a presence of water by this AQ here. So we can then show that this is going to be aqueous KCl based on table F. And then we would just have to make sure that we go ahead and balance it by placing a 2 in front of KCl and a 2 in front of potassium. All right, we already have checked. We know that zinc is going to replace hydrogen. So we have ZnCl. This is +2, this is -1, so we have to show 2 chlorines. We already know that chlorine is soluble except when with silver, lead, and mercury. So Zn will allow this to still be soluble with AQ coming after it. And then hydrogen is diatomic and is a gas. So we can then show that with the H2. And then to balance it, we need a 2 in front of the HCl. And then finally, we have chlorine that's replacing Br. So we then need to write NaCl because this is +1, this is -1. This is going to also be soluble in water, so we're using the AQ. And then Br is diatomic and is a liquid at STP. So here we just need to make sure that we balance this with placing a 2 and then a 2 here. And the rest would be 1s. All right, we also need to talk about something called the net ionic equation. This is when ionic substances basically dissociate and break apart when they're in the aqueous form. So when we had NaClAq, that really means that in the solution we have sodium ions and negative chlorine ions. Ions are no longer stuck together when they're in the aqueous form. So here we have one of the reactions from above. And how we're going to take that is that each of the aqueous ions or compounds, we're going to break apart into their ions. So SrCl2 is getting broken down into Sr plus 2, that's its charge, aqueous, and then the two chlorines separate as well. So we have two separate chlorine ions, which are also Aq. And then any of the solids remain the same. So then what we're going to do is taking that total net ionic equation, we basically look for getting rid of anything that's exactly the same on both sides. So here we have a chloride ion that's Aq, as well as this one that's aqueous as well. So those two we say and call them spectator ions. They basically aren't involved in the reaction at all. So when we go to write our net ionic equation, we basically take them out. So we just show the two parts that are reacting on each side. So we have the strontium aqueous, the solid potassium, and then that's changing into an aqueous potassium ion, and a solid strontium atom. So here's our net ionic. Net just means overall. So once we take out our spectator ions, what's left? So those are the parts that are involved. So let's try out this one. We're going to, again, break apart anything that's aqueous, which this over here should also, should be aqueous. And then we can go ahead, break these all apart, just like we did before. So HCl is being broken down, keeping the two out in front. And then we also have the one zinc and two chlorine. And then again, in this case, we can see that our spectator ions are going to once again be our chloride ions. So these were our spectator ions. These were removed so that I only have my net ionic equation. And again, we're going to talk about this more tomorrow and definitely practice this more, but hopefully you get kind of the general idea and basic understanding what we're looking for. Just make sure again that you go and complete the summary for this concept after watching.